going to be learning how to solve a certain category of questions. Now, these questions are popularly known as hence find questions. Okay, now what really happens is that the question will first ask you to differentiate something, and sometimes it will also tell you that show that dy by dx is equal to a certain expression, and then it's going to ask you to hence find the integral of a certain expression, which will be surprisingly, actually not so surprisingly, but very similar to the one that you got after you differentiated it. So if you've understood what I just said, that's great. If you haven't, nothing to worry about, because that's what I'm here for, and we'll learn it further, we'll understand it further with the help of a couple of questions. So in this video, I'm going to be covering some easier ones, okay, and in the next video, I'll be covering some more complex questions, because these questions are very important, and they're something that you'll find very often in past papers. Okay, so let's get straight to it. So you have given that y is equals to x plus 5 over square root of 2x minus 1, and then it says show that dy by dx is equals to x minus 6 upon square root of 2x minus 1, the whole thing cubed. And then you can see in part B, it's asking you to hence find the integral of something which is, well, in this case, it's exactly the same as you will get after you differentiate it, okay? So here's how this works. This question will just help us understand the basics of it, the crux of it, and then we'll see what happens when things get complicated. Okay, so if you want to differentiate this function, so obviously we'll have to use quotient rule. So u is equals to x plus 5. That means u prime is going to be equal to 1. V is equals to square root of 2x minus 1, but I would rather write that as 2x minus 1 to the power half, because that way I will have it ready to be differentiated. So now I'll multiply it by half, 2x minus 1 to the power half minus 1, and then multiply it by 2. Now what happens is that the 2 and 2 get cancelled out, and now you have V prime, which is equal to 1 over. Now the reason why I'm doing 1 over is so that it looks nice, because the power will be minus half, and if you want to make that positive, you'll have to shift it in the denominator. 1 over square root of, okay, I'll just write that nicely, 2x minus 1. Yeah, there you go. Okay, now quotient rule says that if you have u over v, so I'll write that somewhere over here. So if you have u upon v, so that means dy by dx is equals to vu prime minus uv prime upon v squared. Okay, so I'm just going to apply that over here. So vu prime, I like to make these arrows because that makes things easier to understand. So vu prime means that you have square root of 2x minus 1. Notice how I'm writing the square root version now, because that way our answer will be exactly the way that the question wants it to be. And then you have minus uv prime. So minus uv prime means x plus 5 over square root of 2x minus 1. The whole thing divided by v square. So v square means that the square root of 2x minus 1. The whole thing squared, which in the next step will just cancel out. The square root and the square will just take care of each other, okay? So here's what dy by dx is equal to, folks. And now we're going to take some LCM, do some cross multiplying. And if we do it right, which we will, hopefully, we will get it equal to the way what the question wants it to be equal to. So now you have dy by dx is equals to, the denominator of this is 1, so that means we need to multiply it by 2x minus 1. So that means I'm going to multiply this by 2x minus 1 also. And 2x minus 1 inside the square root multiplied by 2x minus 1 inside the square root means that you're looking at 2x minus 1. And remember, whenever you have an expression right after the minus sign, so it's a good idea to make a bracket, because if you don't, then the signs won't change and you'll get it wrong. And you're going to be upset. So the denominator will be just 2x minus 1. Now remember, this was divided by 2x minus 1. It was upon 2x minus 1, but that means that it's divided by 2x minus 1. And in the next step, we'll change the fraction. We'll bring the numerator into the denominator, and then what will happen is that the division sign will change into multiplication. Okay, like you do with regular fractions. Okay. So now you have 2x minus 1 minus x minus 5 over 2x minus 1 inside the square root multiplied by 1 over 2x minus 1. Okay, now we have a lot of simplification to do. Not a lot actually, but yeah, some simplification to do. So 2x minus x is x, and then minus 1 minus 5 is minus 6. And then in the denominator, you have square root of 2x minus 1, which means 2x minus 1 to the power half, multiplied by 2x minus 1, which means 2x minus 1 to the power 1. So that becomes, now what happens when you multiply the same basis? The powers get added, so half plus 1 means 3 upon 2. And a nicer way of writing this would be that you write x minus 6 as it is, and in the denominator, sorry, you write 2x minus 1, the whole thing cubed, because that's what the power on the numerator is, inside the square root, because that's what the power in the denominator is. So what I'm applying over here is basically this rule, that a to the power m upon n is equals to a power m inside the nth root. Okay, so this is the rule that I'm using over here. Now let's see if I got exactly what I was supposed to. Yes, I did. Okay, so that's part A out of the way. Okay, now part B says, hence find, okay, so let's just write that down. Hence find integral of x minus 6 over 2x minus 1, the whole thing cubed, inside the square root. Okay, now why did the question feel the need to say hence find? Why didn't it just say that find the integral of so and so? That's because that what you just did, that's what you're going to be using to find the integral of this. So whatever we did in part A, that's what we're going to be using to find the integral of this. And whenever the question says hence find, that means you have to use your working from the previous part in order to work it out. Okay, so now here's something that's for us to realize. So we know from prior knowledge that integration is basically the reverse process of differentiation. Okay, so that's not exactly news for us. So we know now that if you differentiate, okay, so I'm just going to write this down. So we're going to park this on the side for now, but let's write this down. We know from prior knowledge that if you differentiate, actually not from prior knowledge, but we know from part A that if you differentiate x plus 5 over square root of 2x minus 1, x plus 5 over square root of 2x minus 1, okay, with respect to x, of course, you get x minus 6 over 2x minus 1, the whole thing cubed, inside the square root. Okay, we just saw this, we just witnessed this live, that if you differentiate x plus 5 over square root of 2x minus 1, you get x minus 6 over square root of 2x minus 1, the whole thing cubed. Okay, so what does that tell us? That tells us that, think of it this way, if you differentiate sine, what you get is cos. Okay, that means if you integrate cos, you get sine. Okay, you get what I'm saying? Integration is the reverse process of differentiation. So this means that if you were to integrate x minus 6 over, okay, let's write this nicely, x minus 6 over 2x minus 1, the whole thing cubed, inside the square root, you should get x plus 5 over square root of 2x minus 1, but with integration, as you know, there we write a plus c. But yeah, what that plus c is not that relevant right now. It is important, don't get me wrong, but what's important is for us to understand that if you differentiate a certain function, a certain expression, you get expression a, let's say, which means if you integrate expression a, you would go back, or you would get the original expression back. So, and that's what we're doing here. So that means if I want to integrate square root x minus x over square root of 2x minus 1, the whole thing cubed, I don't have to do anything at all. I don't have to do any integration at all. I am just going to conclude that this would be equal to x plus 5 over square root of 2x minus 1, and since it's integration, we'll put a plus c. And there you go. This is how hence find questions are solved. Let me tell you that not all of them are going to be so easy. Sometimes you'll have to multiply it by a certain constant. Sometimes you'll have to divide it by a certain constant. But the overall theme remains the same, that you got to be able to somehow use what you did in the previous part to work out the integral of the function that's given in part B. Okay. So I'm going to stop here. That's enough. This is enough for this video. I'll see you guys in the next video with some more complex examples. So until then, take care. Bye-bye.